gold. And when you think about the fact that this soil probably took hundreds of years to form,
Hello, my name is Christine Brown. I'm a field crop sustainability specialist.
welcome everyone. It is a beautiful day in March. We're talking about manure, and it is a Monday, so it must be March Manure Mondays. Welcome back. Week one, we had a great discussion about manure storages and methane. And last week, we talked about fine-tuning manure nutrient availability, another good session. So this week, we're going to drill down a little more, looking at some equipment, looking at the circular economy. We know that manure moves a lot in the countryside, and so how can we make better use of that? And we've got a number of speakers we're going to have to join us for that. So first of all, a quick reminder that we like you to be noisy in the chat, but quiet with your voice, and otherwise be muted on the call itself so that we can hear the speakers. So thank you for joining us, and we look forward to your questions. So I want to jump right in today, and I'm going to welcome Dr. Scott Shearer. And Dr. Shearer was here in Ontario back in January, I guess it was, at the Midwestern Ontario Ag Conference. I got to meet you there. We were talking about precision ag. And it seems, Dr. Shearer, every time we have you speak, you're talking about something cutting edge or technology or the future, something that's interesting and exciting. And I think today is no different. So your slides are up, you're ready to go. I'm going to let you jump right in and introduce your topic, and then we'll go from there.
Well, thank you, Andrew. I appreciate the very kind introduction. Today, what I want to talk about is a product that's been on the market for a few years, but it's a product that I think is beginning to change how we look at specifically animal nutrient management. You'll notice the title for my presentation is High Clearance Robotic Irrigator for In-Season Nutrient Management. Make no mistake about it, what I'm talking about is a product that was put into the marketplace by 360 Yield Center, a company out of Illinois here in the United States, and specifically 360 Rain. We were funded on a project with the National Resource Conservation Service off of what they call the Conservation Innovation Grants Program. This project I'm going to talk about today is a partnership between Ohio State University and one of our contemporaries slightly to the west of us, Iowa State University. And we're going to explore a little bit in-season nutrient management, but I'm going to talk a lot about the technology and what 360 Rain actually could mean to animal producers. So with that, we'll go ahead and get started. If we look at traditional approaches to managing animal nutrient sources, and these cost figures, we can argue how good they are or how bad they are, but we're looking here in the United States anyways, at least in Ohio, about $1.50 per gallon for hauling and applying animal manures. And we can talk about what all goes into that cost. Obviously, one of the big concerns in the state of Ohio is water movement. And when we talk about water movement, we can think about nutrients going through the soil profile as well as nutrients that move off site from the surface. Historically, if we go back a number of years ago, the city of Toledo on the Western Lake Erie Basin was without water for a weekend because of dissolved reactive phosphorus moving into the Western Lake Erie Basin. And obviously, one of the challenges that we're dealing with in the state of Ohio right now is how to reduce dissolved reactive phosphorus movement into the Western Lake Erie Basin. And there's also a lake in west central Ohio that is experiencing similar problems, but we're getting blue-green algae blooms. And one of the concerns is the neurotoxins produced from a particular blue-green algae and the impairment of water quality for recreational purposes in the case of Lake Erie, but also it posed a human health risk in terms of the water supply to the city of Toledo. So I want to kind of get people to think about what this technology might mean to animal producers from a couple different perspectives. Timing, traditional application of animal nutrient sources has been limited to in the springtime before farmers plant, and again late autumn after they harvest the crop. We're talking about a system that really allows farmers to apply all year long. And then obviously we have the management of pits in terms of storing animal nutrient sources and some of the volatility associated with those nutrients and or some of the gases that are liberated from those storage structures, posing local health risks, but also the concern for greenhouse gas emissions. This is 360 Rain. This is the device that's out in the field. We call it a high clearance robotic applicator. There's a couple reasons why we selected that term. We wanted to be not necessarily specific to a product, although there's only really one product that's in the marketplace right now. I anticipate there's a system in Europe that's somewhat similar, but a lot of differences. The machine you're looking at, we call it high clearance because it's able to traffic corn all during the growing season. And the wonderful thing is we have access to that field to apply nutrients all during the growing season. You'll notice there's a hose reel. The width of that hose reel is slightly less than 30 inches. So the hose reel fits down between two rows of corn planted in 30-inch rows. Necessarily, because of the length of hose and the diameter of the hose, that reel ends up being a pretty large diameter, which poses some challenges for moving this machine between fields. And I'll come back and talk about that. It's a tricycle type machine. Actually, all the wheels are driven by electric motors. There is an engine on there that generates electricity and powers the machine through the field. I want to make certain that I differentiate between this and a drag hose system. This is not a drag hose system. I want to remind everybody there's 3,000 foot of hose on this reel, and as the machine's going through the field, it unreels and lays the hose out. And then when it's on its return trip, it's picking that hose up and reeling it back up as it goes back the, in this case, planter pass. I'll talk a little bit about the planter passes coming up here too. The other thing that's unique about this system is it has Y drops on it for placing water and animal nutrient sources and other nutrient sources at the base of the plant. The other thing that's unique about this machine is the orifices on those Y drops are close to 3/4 of an inch in diameter. So when we start thinking about the potential for plugging, I'm not going to say that it's been eliminated. There's times in dairy manure that we'll see some plastic get in there, plastic palpation gloves, hypodermic syringes, and things like that. But as long as you can keep those materials out of the manure, it's fairly immune to solids size in some respects. And I'll come back and talk about the system in terms of managing. We call this a robotic system because it is internet connected. At least here in the States, the company's currently using 360 Yield Centers, currently using Verizon for the connectivity. The uniqueness of the machine, I'm going to kind of key in on the image on the right, is it doesn't make any difference what the size or shape of the field is. It doesn't make any difference how the field was planted. The GNSS or GPS coordinates are recorded when the field is planted. In this case, you can kind of see this central location, which is where the water supply or manure and water supply is coming from. And then you'll see the green is where the hose is being reeled out as the machine moves through the field. It will irrigate in the wings on the way out, and then when it's picking the hose up on the way back, it'll irrigate right behind the machine. So really, the machine is never traversing a wet field. The blue lines over here have already been irrigated. The green line means it's making its first pass out wherever the planter trip has been. And then obviously it'll come back and pick the hose up and then come back and it'll go through the end rows and then move out to the next pass. The machine is monitored. Obviously it has GPS guiding the machine, but it's also monitored. There are some camera combinations on there so the farmer can periodically check and see what's going on. And there are a bunch of fault codes and abilities to kind of check on the health of the machine as it's out in the field. But the other thing is this user interface is web-based. So as long as you can get to the web, smartphone, tablet, whatever it is, you can check on the machine and see how it's doing. We're going to talk a little bit about some of the other infrastructure needed to support the machine. And I'm going to start out, the lower left picture happens to be the well site. This is at the Molly Caron Agricultural Center. The Molly Caron Agricultural Center is part of Ohio State University. It's about 30 miles west of Columbus, and it's where we hold the Farm Science Review. The well is kind of here in the background. There is a commercial fertilizer injection system slightly to the left here. And then the big box, gray box in the center is actually the manure injection system. Over here to the right side, you see this thing that somewhat looks like a semi-trailer. That's actually a frac tank. And if you go back when fracking was at least going on in the United States, there are a number of these frac tanks all over the country now. And there's a bit of a moratorium in the U.S. Obviously, there's elections that go on, so things ebb and flow. But a lot of these are available, and they're about $15,000 a piece. They hold 500 barrels, about 21,000 gallons. But it's a great temporary storage structure for manure. In this case, we have about 150 gallons a minute of water coming out of the well, and then we're mixing about 50 gallons a minute of manure into the water stream for a combined total of about 200 gallons a minute going to the 360 rain unit. We talk about this being a low volume machine. The other thing that I want everybody to know is this is a relatively low speed machine. It moves at a blistering pace of up to 8 inches per second. If you want to do the math, 1/4 to 3/10 of a mile an hour, somewhere around there. So it's a very slow machine. Typically, this machine will cover 160 acres in about 4.5 days. And during that time period, we'll put on the equivalent of about 1/3 of an inch of precipitation. If this machine were dedicated to 160 acres, you can make 12 passes over the field during the growing season and put on about the effective quantity of about 4 inches of precipitation. So those are some of the round numbers. There's really going to be 2 or 3 benefits when we think about this machine. One of those is going to be additional crop growth or additional crop yield from that water, that irrigation water. Obviously, the nutrient source coming from animal manures in this case, and then the ability of being able to apply that animal nutrient source closest to the time in the growing season when the crop really needs the nutrients in some respects. This is another, there are a little bit of infrastructure that goes with this in terms of the base station, if you will. There's some GNSS antennas for the base station. There's also a radio link out to the machine in the field, and this is run with RTK correction. I mentioned there's about 3,000 foot of hose. It's 3-inch diameter hose. It'll take about 120 gallons a minute. You need about 120 PSI to push this through the plastic hose and get out to the boom. Booms are available in either 60 or 80 feet. 12 or 16 drops, wide drops on 60-inch centers. It does have a 24-horse diesel engine on it. This is the same thing same diesel engine used on reefer units for refrigerated over-the-road trucks. The motors on the wheels are 56-volt DC brushless motors. The whole entire control system is 12-volt DC. And then when we get to the base station, if you have an electric well, these technologies can run off either the 240 or the 480 volts. And then the range and speed of the machines from about 5/100ths of a mile an hour up to 4,500ths, or about just a little bit under a half mile an hour. We can go in and talk about a lot of this, but the thing that I think that the take-home message for me is this machine is very accurate. It can again travel 12 times during the growing season. It will make it down between the rows. Really, when you look at any kind of crop damage, it's no worse than a high clearance sprayer going through the field. And so there is obviously a bit of crop damage on the ends where you're turning in the end rows, but outside of that, nothing outside of what you would see in terms of what's going on with high clearance sprayers. This kind of shows the machine in the field a little bit later in the growing season. This lower right picture shows the Y drop depositing the water and nutrient mixture at the base of the plant. And then the other thing, and where a lot of the intellectual property is in this machine, is the system for maintaining the tension in the hose, if you will, as it's reeled out and then picked back up. And this, I think, is one of the more unique features of the system when you think about it from an engineering concept. By the way, you must log the GNSS or GPS coordinates as the machine goes through the field when you're planting. I'll say when the planter goes through the field. And you got to be careful because the planter will wander a little bit behind the tractor. For those of you that have auto steer, the GNS receiver or GPS receiver is going to be on the tractor. Well, we can guide the tractor very accurately. The problem is planter following could have errors that are up to about 10 times what the tractor cross-track error is. And for this reason, we end up putting a second system, if you will, GNSS system for logging the GPS coordinates on the back of there, and that's all logged to the base station. It goes to the cloud, and then the traffic patterns are set up in the field. A little bit on the machine, a relatively light machine. It's about 13,000 pounds empty. When that reel is full of, or that hose reel, if you will, and the hose on it's full of liquid, it's about 24,000 pounds. So a little bit about the machine itself. There is a bit of a chopper arrangement on here on what they call the bucket, which is kind of distributing the manure as it goes out to the Y drops. So there's always agitation and movement in there to make certain that none of those hoses are plugging up to ensure uniform application across the width of the machine. I want to kind of make a comment here about water availability. It's not like you're going to pump manure directly. Now, in some cases, some of the lagoons you might have, if you get some solid settling, you might be able to pump directly out of the lagoons and supply that to the machine. If you have high solids content manure, that's kind of the rationale for tending to mix it with water in some respects. And so again, you just have to be kind of careful what the total solids content is going to the machine and some of your pressure drops. This is a map of Northwest Ohio, and I only put this here because of water availability. In a lot of cases, we look at Northwestern Ohio, while there is adequate groundwater, there's not really enough there to support center pivot irrigation systems that might be in the 800 to 1,000 gallon a minute range. We're talking about a very low volume machine. Obviously, it's going to take a little bit longer. But we begin to look at the blue areas that are kind of outlined in these western counties and northwest counties in Ohio. And we have a lot of wells that will produce 100 to 500 gallon a minute. Again, the hot spot, the ideal spot here is about 200 gallons a minute when we think about makeup water for the machine. So if that is going to be well water, there's a much broader area of the country in some respects where that water is available. Now, the other option is you begin collecting more water, such as roof runoff and some of those sort of things from animal facilities in lagoons. The nice thing about the lagoons, your storage capacity is no longer really a problem in that you're able to apply all during the growing season. So just some things to think about that there in terms of water availability. This is kind of showing a setup on a farm where the main hydrant is. And this is kind of an idealized situation, but you can go out 3,000 feet to this corner right here, which means you're going to make this straight pass and then go across the end rows. And that's when we begin thinking about how many acres the machine, at least in one setting, might be able to cover. The other thing about this machine is that you can move it between locations. It is not a capital asset that is tied to a specific piece of ground, much like a center pivot irrigation system is. Those are a little bit more difficult to move. And so, you know, if we move it next door to this field, the one to the left, pretty easy to do. Again, you're still kind of constrained right now by that 0.5 mile an hour in terms of moving the machine. So makes for a long day if you have to move it very far. Going back to our side a little bit here, on the right-hand side over here, we have our well water. This is the manure injection skid. This right here is commercial fertilizer, and the pump for injecting commercial fertilizer is obviously a lot smaller, but a UAN solution, for example, if we're trying to meet some of our nitrogen needs. The nice thing is we can do combinations, and so it depends upon the timing when we want to make certain that adequate nutrients are available to the plants, but this is kind of the ultimate flexibility in terms of being able to apply nutrients. I mentioned before the frac tanks. We ended up with 2 of these in our field storage location. Then we have our semi, and we're able to track or truck manure, if you stop and think about it, at just about any time. And we have quite a bit of capacity here in terms of our 2 storage tanks, about 44,000 gallons between the 2. And so we can run for several days on injecting 50 gallon a minute of manure into that 150 gallon per minute water stream. These are just some tables looking at, in terms of one setting, how many inches can be applied. So gallons of water, this is to cover a field, gallons of injected manure, and obviously it's going to be about 1/4 or 1/3 of what the water is. And this is just inches applied. And so this kind of gets us to a point where we begin matching up what our animal nutrient source might be with our available land, and we begin thinking about the nutrient aspects of it as well. Over here, if we're putting on 3/10 of an inch of water in a setting, and the number I mentioned before, and the one I like to use is we can cover about 160 acres in 4.5 days. And that's kind of a routine combination of numbers to think about. If we're able to cover the field 12 times during the growing season, it really means we can put on about 4 inches of moisture, if you will, or effective precipitation. This is showing the GNSS receiver that's placed on the planter. In this case, this happens to be a Deere. I think this is a passive steering system, trying to get the planter in the right location. But 360 Rain, 360 Yield Center prefers using their system to track where the planter has been in the field. And again, this is RTK correction, and so you'll see that radio link back to the base station. Also, we're always looking at that connectivity issue in terms of making certain that everything's working correctly. This is a demonstration we did at the Molly Caron Agricultural Center. Obviously, this is a senesced crop, so there'd be no reason to irrigate it. But the reason why I like showing this one is we put some blue dye in the water, and on this particular day at the Farm Science Review, we would do about 5 to 6 demonstrations a day. We did that over 3 days. And you can see the machine is very accurate when we begin to look at the strips of dyed corn stover in the field. And again, we were trying to, we set up this demonstration specifically so people could see how the machine replicated its path in terms of laying out the hose and picking it back up, and really how accurate the machine was. Building a lot of confidence with farmers, this machine is not going to run over crops, rather it will run down between the rows. This happens to be Molly Caron Agricultural Center, where we're doing a lot of our replicated research. And we began looking at the reach of the machine and where we could have field scale investigations. And so I won't go into a lot of things, discussion here, but our well site is right here on the right-hand side, and we run lay flat hose to multiple locations, and then we run the 360 Rain from those locations. We have been looking at lay flat hose. I think we can go up to about 8,000 feet. When you look at the 360 rain, you go another 3,000 feet. We've been using 6-inch hose, which is probably overkill. But then again, we have very low pressure losses. And one of the things we're always concerned with is that pressure at the 360 rain machine to make certain we're getting uniform distribution across the bin. I'm going to show you some data here, and I want to be careful here because we did not get our 360 rain unit until, well, a substantial delay in terms of into the growing season. We put on, and this happens to be corn, and we put on about 1.5 inches of rain or precipitation, effective precipitation, and we had a modest gain in yield. Nothing to get too excited about. It was a good growing season, but again, 226 versus 218 bushel an acre. This one here was in a little bit different situation. We varied our nitrogen application rate, and I think you want to pay attention, 120, 170, and 220 pounds of nitrogen per acre. And we put on about 1.3 inches. This would have been 4 passes with the machine during the growing season. So really, we were looking at this primarily as a nutrient management tool. And over here, if we kind of look at the 220 as being baseline here, with no additional water, we were at about 235. We at the 220 here, we're at 246, but you'll notice that we can cut our nitrogen rate substantially, and we ended up with 245 bushel an acre, with again a reduction of what, 50 bushel, or I'm sorry, 50 pounds of N per acre, still getting effectively the same yield rate. Down here, obviously, without being able to apply the nutrient and get on it at the right time in terms of the crop needs, we're putting on the 220 units of nitrogen and still not quite getting what we were getting with that additional 1.3 inches of water during the growing season. Again, timing is everything, but also when we think about making that nutrient available to the plants and getting it into the soil profile where the roots have access to it because of the water. I'll talk a little bit about this on the orange passes here. We had a replicated study with corn, and this was during the 2024 growing season. On this south side here, this is soybeans, and a lot of people tell us you really can't make money irrigating soybeans. I'm going to remind everybody, last year was a pretty tough growing year in central Ohio because especially southwest Ohio, we were in near drought conditions for a substantial portion of the growing season. So kind of an extreme case in some respects. Here's Molly Cairn Agricultural Center. We were able to put on 5.5 inches of water. When you think about that, that would have been somewhere around, 16 trips through the field, 17 trips. 180 pounds of nitrogen here. We had 136. This was 2/3 of the nutrients. And then down here, we had kind of our standard rain-fed. Our rain-fed corn came out at 189 bushel an acre, where the irrigated corn did 233. That was with the full nitrogen rate, and then 237 with the 1/3 reduction in nitrogen. And so consistently, whether it's favorable growing conditions or in this case, near drought conditions, pretty good yields for a drought, but we're seeing very favorable results in being able to reduce the nutrient application. A lot of this was all done with UAN. We're also very interested in what's happening with the animal nutrient sources. Our counterpart, Iowa State University, is doing a lot with in Iowa with application of animal nutrient sources, seeing some very similar results. This one I think is kind of interesting because this is soybeans. As you might guess, the end of the season in Ohio, the beans were very dry. We ended up with a lot of small beans. The plants senesced very quickly. We had some pretty high shatter losses, but with 4.5 inches of water, we were able to keep those soybean plants greener much longer. And we ended up with 86 bushel an acre on our irrigated beans. We irrigated them towards the second half of the growing season. And then you'll notice that the yield on the rain-fed was 50 bushel an acre. And so it just so happened this year being able to irrigate the beans during when they were blooming and during pod fill had significant advantages in terms of yield. Obviously, we were not applying nutrients in our bean fields. 360 rain benefits, lower water demands. What we're able to do is place the moisture, if you will, at the base of the plant as opposed to watering the entire field, if you want to think of it that way. Efficient delivery of nutrients such as N, P, and K. We're beginning to think about micronutrients, which could be another added benefit. Ability to operate regular shaped fields where other irrigation approaches may not be practical. Triangular fields, long skinny fields, things like that don't lend themselves to center pivot irrigation. Applying manure in season. I think this is going to have significant water quality benefits. And also we're going to get much better utilization of the nutrients that we are applying. NRCS is very interested in how they might be cost sharing on this technology in the future. Less ammonia loss, manure in high oxygen environment converts. We can talk about that in terms of nitrogen. These are some thoughts. Obviously, we need to be collecting some data and verifying some of this in terms of volatilization and loss of nitrogen in other manners. We've had NRCS out in Ohio. We have H2 Ohio, which is a state cost share program. They all see, everyone sees a lot of value in this technology and is beginning to think about how federal and state governments, at least here in Ohio, might be cost sharing with farmers to get this technology in their hands. This is from a website, 360 Rain, and the annual revenue boost, and I think this is kind of something to think about here. As animal producers begin using this technology, there's 2 or 3 things to consider. One of the things that we've been seeing is typically, I mentioned that $0.015 per gallon in terms of variable costs for applying manure, trucking manure down the roads. If we're able to pump it, we drop to about 1/6 of this, 1/5 to 1/6 of this cost. Okay. And really, our existing farmers in Ohio that have purchased these machines, this is the one thing they note is cutting their application cost. Yes, there's going to be a benefit from reduced nitrogen. Will this be consistent? We don't know, but at least in the crop years we've been involved, that could be substantial. And then the other thing is the yield bump. What kind of yield increase are we going to get? And then what's the value of that grain? Just looking at some of these variable savings, if you will, or variable advantages in terms of yield. And again, we can argue these numbers, but if we're able to see that $410 an acre benefit on 175 acres a year, it's about $72,000 a year, which in the case of the 360 rain means a payback period of a little over 3 years, 3.5 years, somewhere in that neighborhood. I want to be careful because it really depends upon the infrastructure in terms of being able to set up and pump water and or meter nutrients into the water stream. I'm going to kind of close out with this last one. I think this is pretty interesting. It's coming in 2026. We hope to have one of these units this year at Ohio State University. This is a granular material inductor. And I'm going to show you a couple videos coming up here. But what they're able to do now is begin introducing granular fertilizers, cover crop seed into that water stream. And we begin to think about what this might mean. In this case, here's a video. This is potash fertilizer being dropped into the water stream. Okay? So now all of a sudden we have added capability instead of placing a drop as that machine is irrigating. This is showing the mixing of that potash within the water stream that's going out to the 360 rain unit in the field. One of the things that we were told is they've demonstrated this with soybeans as a cover crop. And so we begin thinking about what this might mean to dairy producers, being able to interseed some different crops into standing corn crops or other crops, what it might mean in terms of multiple crops per year, and then obviously being able to establish cover crops at the end of the growing season, make certain that they get off to a good start by providing water for drinking. So with that, I just want to recognize This is a NRCS CIG grant from the federal government here in the United States. The Ohio Department of Agriculture has also partnered with us on this. We're beginning to look at how this might be used for improving rural wastewater treatment for small communities. And so we have a potential project coming up this year where we will be partnering with some farmers and land applying or reusing some water from some of these wastewater treatment plants that'll be coming out of lagoons. But we hope to see an added benefit of reduction in loading in the surface waters, and then being able to use that, reuse that water and hopefully turn that into a little bit greater yields and maybe the nutrients into meeting part of the crop needs. There's also been a lot of other contributors to this. Obviously, Iowa State is part of it. Beck's, we're doing part of the work at Beck's, which is one of the private seed corn companies or seed companies here in the United States, and certainly 360 Rain. So with that, I think I've reached the end of my time. I better stop. So
That's just awesome, Dr. Shearer. There has been a lot of discussion in the chat, a lot of questions, a lot of comments. I do want to circle back to a few of them right now, if you don't mind, before we go on to the next speaker. But first and foremost, do you think in the design of this, were they considering manure from the beginning, or really this was about water and manure and everything else that's coming on later?
yeah, and at the onset, I think 360 Yield Center was really looking at this as an irrigation machine, and justifiably so, because they were trying to basically, the question I think initially they were trying to address is, if we could put 4 inches of moisture on, or equivalent of 4 inches of precipitation on at key times during the growing season, what would that mean to a corn crop? What would that mean to a soybean crop, specifically in the Midwest? I think once they introduced this in the marketplace, and again, I think they went to the National Farm Machinery Show and they had farmers fill out interest cards. When they brought those interest cards back, they found out that 80% of the people filling out the cards were actually animal producers. And so immediately, I think they saw the opportunity to look at land application of those animal nutrient sources. And I think that's where a lot of their sales have been to this point in time. So.
Yeah, makes sense. So to circle back, and thank you, Dr. Glenn Arnold's on the call. He's answered some questions in the chat. We also have some folks from Grand River Robotics. That's an Ontario company that they are distributors for this, and so Henry Hutton, Harry Lind, I think, are on the call. They jumped in a few times as well. Thank you for that. One of the questions is about the slope, in terms of what kind of slope can you manage this on? You've been to Ontario, you know we've got some flat land, but we've also got some pretty sloping land. What are the limits?
I want to be careful, because there's what 360 Yield Center says, and then there's what the machine will do. My understanding is generally, if it's cropped, okay, and I'll say corn and soybeans, there's a pretty good chance you're going to be able to operate this machine on that ground. Okay. I think 6, 7, 8% slopes, not much of a concern at all. When it goes beyond that, there might be some concern, but it's pretty amenable to operating on slopes, from what I understand. Most of our work has been on flat ground, so I want to be careful. I'm only sharing things that I've heard in terms of talking with some of the people from 360 Yield Center.
Yeah, fair enough. There was a bit of a discussion about phosphorus levels, limiting levels in Ontario. And Chris Brown mentioned this in the chat, that 60 parts per million is sort of a line that we draw. You have a similar number in Ohio?
Yeah, we're when you look at our 590 NRCS guidelines or whatever, we have situations where we should not be applying because we're above certain levels in the field, and then we'll have conditions where we can only apply to crop removal, and then obviously the deficit areas. One of the things that I think we need to continue to think about in some respects is, you know, not hard, steadfast rules, but generally when we look at manure, the majority of the phosphorus tends to be in the solids component, whereas a majority of the nitrogen tends to be in the liquid component. And so I know there's going to be a speaker coming up next here, but the question really becomes, can we do something a little bit different when we begin looking at higher solids content manures in terms of moving them away from the high phosphorus, or at least soil test regions of fields that are close to the animal production facilities? I'll remind everybody, we can also pump manure, if you will, or pump water a pretty significant distance at a low cost in comparison to loading it on a tractor trailer and moving it down public thoroughfares. And so I want to recognize we're not saying that anybody should apply anything beyond certain soil test levels, and we want to be observant in terms of environmental situations. And again, in the case of our cost share, in almost all cases, farmers are going to have nutrient management plans to take advantage of the cost share. And so I kind of throw those things out there as something to consider.
Yeah. Mark on the call is an Ontario farmer, and he is asking about the possibility of putting splash plates on the bottom to use for application onto wheat.
Yeah, and that's a great point. Actually, 360 Yield Center offers multiple different attachments for the ends of those Y drops for that very reason. And so it all depends upon what your goals are and what you're trying to achieve. But whether you place it at the base of the plant or you spread it out over the entire surface area, you really have latitude to do that with some of the attachments for the machine.
Okay.
Yeah, great point.
Dr. Arnold, actually, if you're able to unmute and come on to the call, maybe you wouldn't mind hearing, your experience particularly with plugging and how the machine handles that with some of the work that you've done. So, Dr. Arnold, are you able to come on the call? Just unmute and start talking if you can.
Yeah, we have about a dozen of these units running up in Northwest Ohio. And some of them put splash plates on them when they want to do the cereal rye in the spring and then after harvest. Pretty intrigued by the thought of putting the cereal rye in with the 360 manure well ahead of harvest time of silage. That'd be kind of neat to get that established. On the plugging issue, when I've watched these things run, I've observed when a unit's been plugged as far as one of the downdrop nozzles. And I've also observed when the whole thing was plugged and manure was squirting out the top of it. So it does happen. My observation has been that usually have an employee come out and make a stop in the field and look to see both machines are running, even though they do have the app on the phone that should tell them that it's working. But when it's working, it doesn't necessarily mean all units are unplugged and everything is going just as it is. So a visual observation is a timely thing every couple hours, I think.
And again, Mark makes a comment, the problem with pumping a blend of manure and water is you need to keep it moving or it'll settle in the bottom of the hose. And that's, he is a swine farmer. So that's his comment in that regard as well.
Yeah, and that's fair. Anytime you're moving solids in a liquid, you always have to be very careful of the velocities that you're using. So yeah, that's a fair statement. So
yeah. Okay. There are a few more questions, but I think we're gonna pause there because we want to make sure to give our next speaker some time, and we'll circle back at the end if we have more time for additional questions on this altogether. But thank you very much, Dr. Shearer. That's is very interesting. I think we're in early stages. Lots more to come, and particularly you get this in the hands of farmers, and they're going to start thinking about this and this and this, and so I think it'll be very interesting. So I do want to introduce an Ontario colleague, Mel Limas, and Mel has been on our calls before. Welcome back, Mel. Mel's Executive Director of OPACA, Ontario Professional Agri-Contractors Association, and also LICO. We LICO you, Mel, but LICO stands for Land Improvement Contractors of Ontario. And Mel, can you just give some comments, Ontario perspective, some of the work you've done around this whole circular economy? Manure moves a lot in the countryside.
Yes.
Mel.
Yeah, thanks, Andrew. Thanks for having me again. Love Manure Mondays. And yeah, this is an interesting space where both of my jobs kind of with drainage and manure kind of can come together. So I love that with irrigation. But and it's a far stretch to call me a speaker, but I just wanted to say a few words about a project that I've been working on. So yeah, OPACA represents the custom workers, farm contractors in Ontario, and well over 50% of our members are doing manure contracting. And so we kind of get called in to talk about manure a bunch. And this time we're doing a project with Agriculture Canada for one of their Living Labs projects. And we're looking at the costs of a few different ways of reducing methane, and separation is one of them. And so I don't have slides. I probably have a few pictures of separators I could share, but I'm right in the thick of it right now. Like deadline is today. So I don't want to share my numbers. I think they're too early to say, but yeah, so separation, this will come back to the 360, I swear. Separation is really, there's a number of ways we can do it. Really just taking the solids out of the liquid portion of the liquid manure. For our project, we're looking very specifically just at dairy and at finishing hog barns, like under barn storages. And what can we do with that manure? So separation, you can separate manure with a screw press. Maybe should I share my screen quick? Just real quick. Just so
Yep.
I'd hate for you not to know what I'm talking about.
No, do it.
A screw press. I'll just a few quick slides here.
Yep, no, that's good.
Obviously, screw press. These are well-used ones. I've taken all these pictures in the last few weeks. Is probably the cheapest way of doing it. But there's also like a slope screen idea, so that the liquid's falling through, and then you can capture the solids separate, and then you can roll it to get a better dry matter. Or there's a centrifuge. And then you start like spinning and get a little bit more expensive, but it also does a better job. And so why would we be separating manure? This is great. Like Jason Oliver's going to love that I took a picture of a slide that from Manure Expo without asking him. So this is a great example of separation is good for methane reduction, for one. It's good for many things, but the amount of like volatile solids that you're taking out of a liquid portion is less feedstock for the methanogens, like the bacteria or archaea that make methane in anaerobic conditions. If they don't have the food, they're not going to make the methane. And so this is just a really great graph that shows that when you separate, you are reducing methane. According to AgriSuite, we've got a 20% reduction of methane by using a separator in dairy manure, and 12% by using it in hog manure. So that's one reason. But another reason you might want it to separate solids is actually for the solid portion, is for bedding. And so I know there's a lot of guys that got scared in the past for using dried manure solids. Some, here, I'll stop sharing my screen. Some have like composted it after. A lot of guys that have digesters are obviously separating and using it. But some guys are doing it green bedding. Like, and these are younger guys, and maybe they didn't get scared by the stories but they're making it work as green bedding is use it right away. Don't stockpile that stuff. It's going to start composting right away. And so they're using it within hours of it being pressed. They have to bed and more than you would have to do it with sand. Like it takes more management. You have to use less bedding, but more often. There's a lot of like hand cleaning that you have to do and different sorts of management. But it can be a huge savings for bedding if you want to use the solids portion. And in general, I think this is for dairy cattle, but like they produce twice as much bedding in their manure than they would need. So you're really only using 50%. You'd only be separating 50% if you're using it just for bedding. People often talk, and I love that slide, Dr. Shearer, about like the value. We're like, if you take manure into two separate streams now, you actually you have to manage both of those streams. And a lot of people have a misconception that the water was just water, and that solid portion is now like, ooh, it's just all gold, like all the nutrients are in there. But that's not true, unfortunately. Think of the liquid portion, these are rough estimations, they might be wrong, but like you would assume like 90% of the ammonia and nitrogen is in the liquid portion, 20% of the phosphorus, 90% of the potassium. Whereas in the solid portion, you get more of the organic N and the phosphorus. And so now, but you still have to manage both of them. And that was always the issue, because that solid material, I think just looking at raw values, when I broke it out that way, it's it has 60% more value than the liquid portion. So it'll travel twice the distance. Like you could take it 10 kilometers or more quite economically.
Yeah, I mean,
For
Dr.
land
Shearer
application.
said, what did he say? 1.5 cents per gallon to haul.
Yes, but now it's a dry solid, but now it's dry. Now you need a solid spreader, right? So the issue, and this has been the issue, is like, well, what do you do with the liquid portion? Like, because now it's not going to go anywhere.
Right, right.
But unless you have, and here, this is why it's coming back to the 360 is that's a really great way of really increasing yields. It might have, you might say, oh, it doesn't have a nutrient value. It has value as water. Remember that we need water for irrigation. But the other reason you might separate is for water, but not for irrigation. It's for a flush barn. The better water quality that you have, the better it's going to work in a flush barn. Or if you're doing sand separation, again, the better quality of water that you have, the more easily that you can separate sand. And so there's lots of reasons why to separate. Like at first instance, it sounds like, oh, now you're just creating two different problems. But if you can see each of them as now a unique sort of, whether it's for the nutrients or whether it's just is purely for the water, because we need water, then it just starts changing. And I've for this project with Agriculture Canada, I've got to talk with the best farmers in Ontario that are doing separation and these other technologies. We're looking at acidification, cover and flare, and aeration. And so it's been a great time talking with these farmers and a lot of really young, interesting folks trying to think of manure differently. And so I'm super excited to see what the 360 might allow us to do in the future.
Excellent. Love it. Appreciate your comments, Mel.
Mm-hmm.
Dr. Quinn, bring Dr. Shearer back on here to the panel with us. And also, I noticed that Carl Brubaker is on the line. Carl, can I put you on the spot? Carl, who is a farm, has a swine operation in Arthur, Ontario. And Carl, I believe you're going to be trialing this product on or this machine on your farm this summer. I'm just curious, Carl, why? What are you hoping for? What are your plans? So Carl, or if you're able to unmute, come on and make a comment.
Can you hear me there?
Yes, we can.
Okay. Hi, Andrew.
Hi, Carl.
Not quite this summer. Time goes by too quickly, but hopefully for 26.
26?
Fingers crossed. Okay.
No? Sounds good. So what interests you though when you see this?
Lots of things. Soil health in the end of it all, and the really efficient way of applying nutrients so we can grow more corn with less nutrients. And environmentally as well, just, you know, we got the creek behind us and less runoff risk, all kinds of things.
Yeah, we didn't talk a lot about that. In fact, I know there was a question earlier, Scott, that somebody had asked about phosphorus runoff. Is that something you've done work on, or it's in the plans yet to come?
The only thing I can really talk about is anecdotal evidence. One of the things when you're only putting on 1/3 of an inch of effective precipitation each run, really what it boils down to is how much water was in the soil before you started. Okay, as long as it's usually pretty good conditions, we don't see much movement at all of water within the fields. In other words, It's going into the soil and it's percolating down through the soil. We save very little water movement on the surface. Now, again, I want to remind everybody, all of our application has been on relatively flat ground. We haven't done much on hillsides. But again, if you're thinking about a third of an inch of precipitation, it's not a lot of water. And I'm going to say, depending upon local soil conditions, if it hadn't rained for several days, the oil or the soil ought to be able to absorb that 1/3 of an inch of precipitation with very little, I'm going to say, surface movement of water. So
I do have to say, and I don't know who made the decision, where in the process they did, but I was so glad for the design, the down and back, that it spreads on the wings first and it doesn't drive on its own moisture. Just for compaction, like I trust that that's what somebody is thinking about when they made that decision, and I'm so glad for that because that'll make a huge difference.
yeah, it may not have been the original design, but I think they figured it out pretty quickly. So
Oh boy. Just circling back here to see if there's some questions I've missed. Mel, any other comments you want to make?
I'd be interested to see if we start tile draining into some irrigation ponds more often. I did hear of one instance of a farmer here that is using his water. He's running it through a pivot. Again, that's always the issue is with plugging a pivot. So that's what I appreciate about the 360 is that you can get more solids in there. But can you start tile draining into those earthen lagoons and never letting go of that water to begin with for some drainage water recycling?
Mel, I'll share kind of an interesting anecdote. There was my colleague was talking about a dozen of these machines in Northwest Ohio. There was a farmer up there who got one the first season and began irrigating out of his lagoon. And several weeks into the irrigation period, he ran out of water in his lagoon. And, it was a different mindset for a lot of these animal producers because usually they're fighting the other problems
Exactly.
with their lagoons before they get to harvest time where they can reapply. So it's an interesting challenge in some respects because it used to be we looked at diverting rainwater from the roof away from the lagoons. Now we might be diverting it into
Now
the
we're putting
lagoon.
it in.
Yeah. So
I know it's so funny how when you have like a new goal, the whole thing changes, right? Now you look at manure differently. Now you're looking at your water differently, and yeah.
There is one more question here, fairly technical, Dr. Shearer. Trials being done so far, have you noticed any increase of micro aggregate production in the rhizosphere?
that is a nice technical one. I got to admit, a little bit out of my area of expertise. Okay.
Oh, I'll answer that one. No, just kidding.
Perfect.
Yeah, I'm sorry I don't think that any of us can answer this right now, so we'll pass on that one. But listen, this has been a wonderful discussion. A little bit of a plug, Manure Expo this summer, July 30, 31st. Dr. Arnold says that the unit we've discussed will actually be demonstrated there at Manure Expo, so that's another reason to go to that great event this summer. But listen, on behalf of March Manure Mondays, Mel and Scott, thank you so much for your time. Interesting discussion. We look forward to having everybody back next week as we look at compaction. So good follow-up to what we've done here. And so we'll see you the same time, same place next week. Have a great week, everyone. Cheers.
Thank you.
Thank you.